So we practiced inequalities before. An example, if I said x is greater than 5. And this x greater than 5 can refer to a lot of things. It could be 5 feet on a ride. You have to be taller than 5 feet to ride this ride, right? This could refer to feet. This could be age. You have to be older than 5 years old. In some cases, we have x is less than, let's say, 3. And this could be, again, referring to whatever you want. This could be the idea of height under 3 feet. If you guys ever went to a McDonald's play gym, you have to be short to go in there. If you were taller, you probably get stuck. Sometimes you see a parent jump in there and you're like, uh-oh. This could be an age thing, under age of 3. Right? Toddlers, like under age of 3, I think. So what if we mix them together? And we're going to call this a compound inequality. So the game goes now, what if, let's look at a number line, and let's call it 0. And for compound inequalities and graphing them, it's actually quite easy. You just have to graph the two numbers that are given. They gave me a 5 and a 3. 5 is up here, 3 is down here. 5 and 3. Then what type of inequality is this? Is this an equal or non-equal one? These are both non-equals. So we draw holes on them. Okay, they're empty. Now the following question is, to graph this, what would I have to, to graph this, what would I have to shade in? Well, let's do them individually. For x is less than 3, let's take a look. Well, here's 3. Now less than 3 would go to the left. For the first one, x is greater than 5. Well, here's 5, right? And greater than 5 goes to the right. So to draw this a little nicer, if we were drawing a compound inequality, I'm going to draw exactly the same thing. You don't have to redraw it if you don't want to. Our steps are 1, put a mark on the numbers that you see. I see a 3 and I see a 5. Okay, so step 1, just draw out the numbers. Is that going to be a hollow or solid? Step 2, just read the directions. Directions say here, less than 3. So you draw a line going left of 3 and draw a little arrow. We're going to go less than 3 all the way, no matter how far this line goes. Next one, x is greater than 5. Well, you can name a number greater than 5. 6, 7, 8, 9, 10. These are all on the right, right? 6, 7, 8, 9, 10. So draw an arrow to the right. So I want you guys to think of a number that could possibly be bigger than 5 and also less than 3. Would that number exist? Would a number exist that's bigger than 5 and less than 3? So let me change this a little bit. Imagine if I asked you an age question. Can you be older than 5 and younger than 3 at the same time? You can't, right? So this type of compound inequality is called an OR. I want answers that are less than 3 or x is greater than 5. Now, does this actually apply in real life? Yeah. Imagine this was a clock and a time system. And remember, time kind of goes through a 24-hour period. Like it goes to 12 and resets. So we're going to just kind of push through that. But imagine if you're busy from 3 to 5 every day. You were busy from 3 to 5. So let me draw this out. From 3 to 5, you were busy. And your friend says, hey, can I call you today? So you say, yeah, call me anytime before 3 or, see the other word or, after 5. Is that something you could say? Yeah. So the idea of an or statement is that it's okay to call me before or after, before 3 or after 5. And the idea of a compound inequality is that it's no longer just one inequality, it's several situations put together. We have more than one option. And in the real world, there's often more than one option. Like, let's take that example of the McDonald's jungle gym, the playground. You have to be between a certain age. It's like you have to be older than 1 and under 4. Okay, right? Older than 1, but under 4. Because if you weren't, you probably get lost in the gym and start like sit there and cry. Okay, so here's our example of that. Let's go take a look at another example of a or. If I ask you, x is less than or equal to 5, and x is greater than or equal to, let's do 6. Maybe you have dinner every day at 5. So don't call me till past 6. Call me either before 5 or past 6. So draw the number line. I'm calling 0 there. We're going to mark out our points 5 and 6. 5 and 6. Now, here's the biggest mistake that people often do. They put the wrong type of dot. So is 5 a solid or hollow? Okay. So is 5 a solid or hollow? So in the participant section, can you guys click yes for solid and no for hollow? So yes for solid and no for hollow. Great, thank you for participating. I see most of you guys are right on target. So the yes has it. So 5 is a solid dot. That means you are allowed to be equal to 5. Looking back at our last problem up here, we were not allowed to be equal to 5. Sorry, we were not allowed to be equal to 3. And the next dot, 6, that's also a greater than or equal. So now we just fill in the arrow, which way do you want to go? For x is less than 5, numbers less than 5s are 4, 3, 2, 1. 4, 3, 2, 1. Numbers that are bigger than 6, 7, 8, 9. All these are on the right side. So this is how we graph a easy compound inequality. And this is what we call an or statement. It's either or. You can be less than 5 or greater than 6. But you can't be both, because that doesn't make any sense. There's no number that's bigger than 5 and also bigger than 6, but also less than 5. Doesn't make any sense. Okay? So or is a huge thing. Like we use the or word all the time. Okay? So we use it also in different contexts. Like if someone asks you, do you want ice cream or pie for dessert? And then you can say, can you make that into an and? Ice cream and pie? So here's our next word, and that's the word we're talking about. It's our and statement. And. So I'm going to show you guys it a little differently. I'm going to say x is less than 5 and x is greater than 3, using those very similar numbers. And let's see if this is possible. Can you guys think of a number that is greater than 3 but less than 5? If you can think of a number, can you type that in the chat? Any numbers that you want? Ooh, yeah, you guys picked the easy one. Good job. 4. Yeah. 4 is a number that's bigger than 3 and it's less than 5. And this idea of inequalities, 3.5, thank you. Good job. So to draw this out, because remember, you guys gave me one answer, but there's an infinitely many set. So let's go ahead and draw our number line like what we did before. Draw 0 and just mark the numbers for 3 and 5. Right? Don't make a judgment call. 4.9, thanks. So all of these answers are right. These are answers that are bigger than 3, but less than 5. Ask yourself, would I do a solid dot or a hollow dot? So go ahead and do that right now. Would you do a solid dot or a hollow dot? You're probably saying hollow. Some do a hollow. The reason why, because it's not equal. Right? This would look like this symbol. And then for now, I'm gonna draw this a little differently, just so you guys can see. I'm gonna make it like super crazy obvious. So x is less than 5. And x has to be greater than 3. So I want you guys to notice that the only part that's true is in between here. All this other stuff doesn't count because it's not an and. Like, here's an example. If I pick the number 6, well, 6 is greater than 3, yeah. But 6 is not less than 5. So you can't have it both ways here. So some numbers don't fit both patterns. So what we do is we draw a line in between. Let's do the problem one more time the same way. If you feel you got it, you don't have to draw the second line. We're just going through it again. When we first see these types of problems, we first mark out on the number line the numbers that we have. We have a number 3 and number 5. Now that we have 3 and 5, would that be a solid dot or a hollow dot? Because they are not equal to, they are both hollow in this case. And then we ask ourselves, another way is just instead of drawing these huge arrows, draw little tiny arrows, just as we're reading this. X is less than 5. Do you see how we're going into the left there? And x is greater than 3 for my next one. Oh, look, they overlap. They overlap right in the middle. And this is what we call an and statement. Right? X is greater than 3, and x is less than 5 at the same time. And for and statements, these type of compound inequalities, we actually have a special way of writing it. We can rewrite it as, you guys ever play monkey in the middle? Right? Where you keep your little brother in the middle and you throw the ball over his head repeatedly. And you think it's so funny, but he himself finds it frustrating. Maybe you are that monkey in the middle. So here's how it goes. We're going to put x as a monkey in the middle. And isn't x less than 5? And x is greater than 3 at the same time. So x, let me guys show you this. I'm going to write this in a silly way. X is bigger than 3, but smaller than 5. X is bigger than 3. It's also smaller than 5. So you can plug in all the values that you guys wrote on the chat. You guys wrote 4. Yes, 4 is bigger than 3, but less than 5. 4.9 is bigger than 3, but less than 5. 3.5 is bigger than 3, but less than 5. Now, in the real world, you tell this to your friends all the time. Hey, I'm free between 3 and 5. And your dumb friend, I mean your good friend, says, hey, can I call you at 4? Yes. Or can you hang out at 4:30? Yes. I told you, I'm free between 3 and 5. Why are we dealing with this? So these compound inequalities can be written in 2 ways. So you just want to be aware. In this case, if I write, let's do another one. We'll say x is less than 7, but x is greater than or equal to -1. Okay, so if I ask you to graph this system, my number line, let's go to first step, is we are going to graph the numbers. So I see -1 and 7. Look how accurate my number line is. So accurate, Mr. Ko. Okay, it's not. Which one would be hollow and which one would be solid? I want you guys to go ahead and try this right now yourself. Color in the hollow and color in the solid. So I see that 7 is a hollow and -1 is going to be solid. Please notice it is equal to, it is not equal to. Don't touch it. Don't you touch it. And then we go ahead and draw little arrows. First question here, x is less than 7. Less than means I'm going to be less than. So you can look at my little arrow there. On -1, x is greater than. Just drawing a little arrow just so I can get an idea what's going on. hey, look, there's overlap. So we're going to color in the line in between. See, so that means all the numbers in between -1 and 7 are totally valid. We can use them all. Use them all. Okay. So next part of this is we can rewrite this inequality. Because we see that this is an and now, we can rewrite it. -1 is on the left, 7's on the right, and we can stick x in the middle. Okay, so when you write it, it looks very similar to that graph. So again, let me show you. -1 is on the left. The bigger number, 7, is on the right, and x is stuck in between. So whenever you see this compound inequality written in this fashion, where they're stuck as one long line, instead of two separate equations, we automatically know it's an and. You cannot write an or equation this way. Or equations will always be written in two sentences, in two math sentences, like up here. Or statements are always written in two sentences because they never overlap. Okay, so let's take a look at IXL activity very quick, and then we'll go into more of the algebra stuff. We're going to look at K.12. I think that's going to be it. So in your IXL activity, you're going to be graphing these compound inequalities. So look at the steps. The steps are written here. It says plot the endpoints first. Okay, that means I see the number 5, and I see the number 7. But, do you see, here's the problem that you might mess up on. These are both solid points. I don't want solid points. Which of these are hollow? Take a look up here. I want you to all notice the 7 is equal to, but the 5 is not. And that means something for us. So we're going to tap, I'm going to tap on the 5 and it makes a hollow. Submit. -7, put a dot, and -2, put a dot. Both of these guys are equal signs. If you take a look there, oops. If you take a look here, see that's a less than or equal to, less than or equal to. Oops. -7 and 2, and drew the line for us. Okay. Let's go jump on ahead. So today for IXL, you're going to only do up to 55 SMART score, but you have 4 of these to do. But it's super fast. So let's go ahead and graph our points. Let's do x is 2, and x is 4. Let's see. So what I would do, I would just double check. X is bigger than 2, so we're on the right side. But x is also less than 4, so we're going left. We're totally cool. Double check. Hollow or solid? Hollow or solid? These are both solid. -7, -1. Now rereading this, one of these guys are going to be hollow. One on the left. And the one way you can make sure your brain makes sense of this, look, x is between the two numbers. So x is stuck. Any of these values between the two numbers are okay. And the graph shows us, is 0 okay? Well, no, that's not between the two numbers. Is 1 okay? Nope. So it makes it very obvious for us. So all the values in between work. And this last one I have to do, this is a huge number, 850 and 845. Now, if I submit it right now, it's going to be wrong. because I'm rushing it because of the inequalities. So tap those inequalities. So k dot 2, no, k dot 13. Let's see what that looks like. K dot 13, they're going to ask you now to write the inequality. So as you can see, they all have 5, 6, 5, 6, 5, 6, 5, 6. So you have to be very careful that you pick the right one. So x is less than 5. 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 Yep. X is greater than 6. Turns out these are all practically the same, except the dots. So this is hollow. That means you can't be equal to. This guy's equal to. That's wrong. This guy is less than. Oh, that could be it. This one is equal to. Nope, can't be this one because it's not solid. The last one is up here, which is less than, which works. So which of these two? Well, 6 is also hollow. So we would choose the one on the right. Okay, a compound inequality. So they're going to have you write this. Now, after a while, they're going to have you write it yourself. So let's go ahead and write this. The numbers that are here are -8. And let's see, we want to be x is greater than, oops, you can't see it. Is greater than, oops, other way around. Less than x, and we're going to choose less than again. Oh, darn it. Less than -4 on the right. Okay, so you're going to practice writing these out. Or you can write this way, an or version, and I'll accept them both. Just write the second one in the or version. So we're going to write two separate sentences separated by the word or. So x is less than, I see that that's a less than sign, less than 5. That's my first one. Or x is greater than or equal to 6. Okay, all right, let's go back to our notes. Now, those examples are the ones that were already set up for you. But now we're going to go ahead and solve our own inequalities. So let's go ahead and come up with one. If I say x plus 3 is less than 7, or x minus 2 is greater than 9. Okay, so look at this. I gave you two separate problems. So whenever you see two separate problems here, just solve them separately. Let's solve the first one, and then we'll solve the second one. And then we'll regraph it once we're done solving it. Let's solve for x in both situations. To solve for x, how do I get rid of a plus 3? I want to ask you, get out of my room, please. I need you to leave. So you have to ask the right question. Remember, I joked about asking your parents to leave. Just got to find the right question to get your parents to leave. Don't yell at them. Makes them want to stay longer. So what's the opposite of plus 3? Opposite of plus is a minus 3, and we do that to both sides to be equal. When your mother leaves the room, she doesn't just disappear. She just goes into the next room. She goes into the next room. And this inequality does not change. For on the right side, plus 2, so that's the opposite of minus 2. X is greater than 11. Remember, there's a rule. We only flip the inequality when we multiply or divide across by a negative. Okay, now we can try drawing this. Our numbers are, oops, Numbers are 4, and numbers are 11. If you want, you can draw 0 over here. You can draw 0 in the middle. That's fine. All number lines, if you draw them correctly, they're always going to be right. I'll take them all. Now, x here is less than 4. That means we do hollow and less than 4. On the right, x is bigger than 11. Well, hollow, because it's strictly greater than, and we're greater than. So here's the big takeaway. We do not graph these right here. We simplify, and then we can graph. Okay, we always simplify, and then we can graph. Now, to be good at these, really you have to be good at our last test when it came to solving equations. So here is our new type version, and this is for and. These are for and ones, and the and ones are the ones that look ugly. Oops. And inequalities. So remember, we can write an and inequality like this. 3 is less than x is less than 5. Okay? And what this really is me taking two separate problems and mixing them together. I take two separate problems and I'm mixing it together. So you can write them separately if you want to, but I don't want to do that extra work. Okay? This equation here is really two separate problems. It's really two. But we're looking at it as one. Look like one. Now, I want you guys to ask yourself, which one looks easier visually to understand what numbers work? Does the left one look easier to understand, that x is stuck between 3 and 5? Or does the right one look easier to you, that make you understand that x is stuck between 3 and 5? I think the left one does. Because you're stuck between 3 and 5. You're literally stuck between two people. You're stuck between mom and dad, between 3 and 5. So we're going to work with this one here. I want to elaborate on it. So here we go. We're going to say 1 less than x minus 2 is less than 3. 1 is less than x minus 2 is less than 3. Now, the general idea of algebra is what numbers would work. And can you think of a number when I plug in x, when I minus 2 from it, would still be less than 3 and greater than 1? And I think that's a hard question to ask. Think of a number that after you minus 2 to it, quickly, that will be less than 3 and greater than 1. I think that'd be hard to ask, especially if this had a fraction to it, if there was a multiplication to it, there's a lot of other steps to it. This is just a simple problem. But here is our trick. Remember I said that this is really two separate problems. 1 less than x minus 2, and x minus 2 is less than 3. This is what it really is. Two separate problems. Now, on the right, how would you solve this first problem? What number would you get rid of? You would get rid of the minus 2. So once you write plus 2 on both sides, x is still greater than 3. On the right equation, would you do the exact same move? You would, right? Wouldn't you try to get rid of that too? X is less than 5. So to save us that work, I want you guys to agree with me that we did the same exact thing to both these equations. You guys agree? Same exact thing? So we're going to skip a step. We're going to make this a little bit easier. And here is the rule for all these compound inequalities. What you do to one side, take a look here. If I'm going to add 2 to one side, I just add it to the other. I end up doing the same process to both sides. Now, let me show you what I mean. So if I just look at the left side, wouldn't I have added 2 to solve this problem? If we were in real life, I would actually use my hand and cover up that right screen, but I can't because I don't have a hand here. You just cover up the right side. Cover up the left side. Isn't that just the problem on the right? Wouldn't we have added 2 to solve for the right part? Let me say this again. To solve a compound inequality, if you're not sure what to do, cover it up with your hand. We were going to get rid of that too. So we add 2 to one side. And if we add 2 to one side, we were going to add it to both sides. And when we do this problem, oops. So 1 plus 2 is 3. The 2's cancel out, and we're left with x and 5. And that's our answer from before. So I'm going to make this problem a little more complicated. We're going to say 2 less than, here's my next example, x plus 3 divided by 5 less than or equal to, let's say 4. So this is a compound inequality again. Compound inequality. My goal is to find out what numbers that work for x. Now, as I joked around before, I could just use my hand. Everyone, please take your hand and cover the left side of the notes. Cover your hand and use your hand. Don't use your pencil, just use your hand and cover the left side of your notes. Have we seen problems like this before? Hopefully you have. So looking at the problem right now, after I've covered it on your notes, do you get rid of the 3 first or the 5 first? Okay, in the chat, please type which number I get rid of first, the 3 or the 5. Thank you. So I made the problem that looked hard. I'm going to just do it one step at a time. And what I do to the right, I'm going to do to the left. So I'm going to multiply both sides by 5. So just squeeze that 5 in there. I'm multiplying it by 5. That means I have to multiply the right side by 5 too. If I multiply the right side by 5, I also have to multiply the left side by 5. So everyone's being multiplied by 5. Did we do that before? Yeah. We added 2 to all 3 parts. So the idea here is whatever you do to one part, you do it to all parts. These are the 3 amigos here. So if I multiply by 5, that cancels out. We're left with 10 less than x plus 3 less than equal to 20. I like that. Now my next move is to solve for x. Remember, we want x to be alone. Our goal is to get this guy alone. We need to get rid of the 3. So how do we get rid of the 3? Opposite of plus 3 is minus 3. And if I minus 3 to one side, I have to minus 3 to all sides. That's 7 is less than negative 3, which is less than or equal to 17. So I'm going to pick a number to check. And a number between 7 and 13. Think of a number that if I add 3 to it, you can still divide by 5. Think of a number that if I add 3 to it, you can still divide by 5. Can anyone think of a number that you can add 3 to it and still divide by 5? That's between 12, so between 7, I said the answer. Oh gosh. That's between 7 and 17, okay? So I said the answer, 12. Is 12 between 7 and 17? Oh darn it, why did I write negative 3 there? Sorry, I'm so sorry about this. This is not negative 3, right? It's not negative 3, I'm so sorry. That's just x, right? That's all that's left over. Sorry about that. So x has to be a number between 7 and 17. So if I write 12 here. 12 plus 3 is 15. And 15 divided by 3, so by 5, is 3. Hey, and 3 is between 2 and 4. That was an answer that worked. Turns out any of the answers between 7 and 17 actually will make that a true statement. Though they might be decimal, it would make it a true statement. Okay, I want to do one more of these problems that look a little funky. Alrighty, give you guys some time to copy it. So we'll say 3 is less than x minus 4 over, let's do 2, less than 6. Okay, so inequality. So first step, do you guys want to get, if you're not sure what to do, remember, just use your hand and cover up the left side like it doesn't exist. That's totally okay. If you're right-handed, maybe you cover up the right side. So what's my first step? Do we get rid of the 4 or the 2? Hopefully you guys are getting better at this. And we're going to get rid of the 2, multiply 2 to both sides. When you multiply everyone, I multiplied everybody, all 3 amigos, by 2, we end up with 6 less than or equal to x minus 4 less than 12. And again, we're practicing solving equations like we did before. That's why I said this was super important. We're going to continue to solve equations for the full year. And add 4, opposite of minus 4 is plus 4. 10 less than or equal to x less than 16. Okay, now if you pick a number between 10 and 16, let's pick 14. Okay, 14. 14 minus 4 is 10. 10 divided by 2 is 5. Hey, 5 is between 3 and 6. Let's pick another number. Let's pick 12. Because 12 is between 10 and 16. So 12 minus 4 is 8. 8 divided by 2 is 4. Hey, that works too. 4 is between 3 and 6. Okay.